Hello and welcome back to this introductory calculus series. Today we're going to be looking at the slope of a graph and tangent lines. So first of all we're going to take a look at the function fx equal to x squared, and I'll quickly draw a little bit of a graph to see what that function looks like. So we're going to have our y-axis here, and a bit lower down our x-axis, and then function will look kind of like this. Oh, it does touch the origin, like that. So first of all it slopes downwards really quickly, and it slows down, and eventually it becomes horizontal when it touches the x-axis, and then it goes upwards, upwards, upwards all the way out to infinity. Alright, so what we're going to do is we're going to look at a certain point on this graph. Let's call it point P right here, with an x-coordinate of 2, and then obviously the corresponding y-coordinate will be 2 squared. That's going to be 4. So we're going to look at the slope of f of x at the point P. So how are we going to do that? Well, we can see if we draw a line kind of parallel to the graph at point P, so that would be kind of like, oh, have to do this a little bit carefully, kind of like this, and we figure out the slope of this line, then we kind of know what the slope of the graph is at P, right? So how do we figure out this line? I'm actually going to call this line K. Well, what we're going to need to do is we're going to let's zoom into this area over here. So we're going to have a little bit like that. So this is the graph. Here we have point P, and we want kind of a tangent line, right? A line that is parallel to the graph at point P. And to do that, because if we want to create a line, we'll need y, so like that, y equals ax plus b. Remember, we have a equals to the difference in y divided by the difference in x, or delta y divided by delta x. That was covered in part 1 of this series. But we do need 2 points for that. We can't just put in point P. No, we need 2 points for that. So what we're going to do is we're going to actually go a little bit further along the graph, just a tiny bit further, and we're going to put point Q. So point Q will be something like 2.01, and then the corresponding output on the graph, that will be 2.01 squared, which is going to be like 4.04. Right, so it's just a tiny bit to the side. And now what we're going to do is we're going to actually just make a tangent line through those 2 points. So let's do that. In green, that's nice. Alright. So we have our point P, that's 2, 4, and Q, that's 2.01, 4.04. And we'll just use the formula, the second y-coordinate minus the first y-coordinate, and the second x-coordinate minus the first. Alright, and now we'll just plug this in, see what it gives. That's going to be 2.01 minus 2. Oh, actually, that's not correct. That should be 4.04 minus 4, like that. Alright, and this is going to be, put it in my calculator, that's exactly 4. So we can see that, and that also corresponds quite nicely with how steeply the graph appears to be sloping upwards, because we saw in the last video that a steeper slope like this would be, for example, a equals 1, and an a equals 4 would be quite steep, like that. And we can see that it corresponds with how steep the graph kind of slopes upwards. So what we did here in this video is we took a function f of x, we picked a certain point P, and we wanted to figure out the slope of the graph at that point. And to do that, we kind of created a second point that is slightly offset of the first point, like a tiny difference, like 0.1. And then we created a tangent line through those 2 points, P and Q, and we calculated the slope of that tangent line. And that's the way that you can get the slope of a graph sort of around a certain point. Obviously, it will not quite be correct because we have like a slight error. But if you pick smaller and smaller, offsets, then the error will get smaller and smaller. Alright, so I'll do just one more example while we're here. We'll do the function, let's put it in blue, the function f of x equals x cubed. And now what we're going to do is because this function kind of looks like this, like that. And actually at the origin right here, let me put that in a different color. At the origin, this function is actually a horizontal, or at least it looks horizontal. So the tangent line should be horizontal too, which means that this slope should be 0, right? Because if it slopes upwards, then the slope is positive, and if it slopes downwards, the slope is negative. But if it's exactly horizontal, then the slope is, that's not exactly horizontal, like that. Then the slope should be 0. So so let's find out. Let's find out if this function is actually horizontal in the origin. So we're going to do the exact same thing. We'll have our first point P, that's going to be the origin, 0, 0, and then the second point Q, that's going to be just slightly offset like that, and then the corresponding output, that's going to be 0.01. Put into the formula, 0.01 cubes, that's absolutely tiny, that is 0. Well, no, let me just divide it as a power of 10 to the negative 6. That's like 0. with 6 zeros, right? Or 5, I don't really know. Well, let's figure out the slope of the line through these 2 points. That's going to be A, the difference in y divided by the difference in x. The difference in y, well, that's 10 to the negative 6 minus 0, so that's just 10 to the negative 6. And then the difference in x, that is divided by, subtracted by rather. So that's just going to be this, 0.01, which is going to be 0.0001, I believe. Maybe it's one more. No, that's correct. Okay, which is, well, it's basically 0, right? But because we have a tiny offset, it will be a tiny bit incorrect. So yes, it does appear that this function, f of x equals x cubed, is horizontal in the origin. So that's an application for this tangent line and these slopes, but it will obviously be expanded upon as we continue this series.